Good morning, everyone. Welcome to class. Today, we are going to do more than just calculate averages. We are going to question them. Because in the real world, especially in the gig economy, numbers like the mean are often used to tell a story and not always the full one. In this class, we'll break down the key characteristics that shape how businesses, platforms, and even government measure economic reality. You will learn what the mean, median, and mode really tell you and what they don't, how to spot when a distribution is misleading, how businesses use these stats to segment customers and apply price discrimination. And we'll walk through a real case study while going through the course for today. So let's go into understanding the concepts that we have before us. That is the mean, the median, and the mode. The mean is what most people or most of us commonly call the average. To get the mean, you add up all the values and divide by how many values there are. The mean gives us a general sense of income, consumption, or expenditure, but it is vulnerable to distortion by extreme value, what we call outliers. And we are going to see how that happens in this class. Now let's go to the median. The median is the middle value when the data is sorted. If we have an odd number of values, it is the exact middle. If even, it is the average of two middle values. You get that, right? So before we can determine the median, we have to ensure that we sort our values, okay? That the values are sorted, okay? So the median is resistant to outliers, making it more reliable in skewed data set like income or wealth, all right? So you see that even though the average is a measure of central tendency, the median in skewed data set is more resistant to outliers, making it really reliable as in a measure of central tendency. So what about the mode? The mode is the most frequently occurring value in a data set. It is particularly useful in categorical or discrete data sets. So, like I said, the median is resistant to outliers, making it more reliable in skewed data sets like income or wealth. The example is, imagine that you are finding or studying the wealth or the income of people aged 30 to 35. You'll find out that the data set you get will be skewed in the sense that it will not follow a normal distribution, that is a bell curve distribution, because many people might be earning way extremely high and some will be earning extremely low, right? So you may not have an even distribution of people who earn high and people who earn low. You might not just have an even distribution within that earning bracket. So it's possible that if you get the mean of such numbers, it's possible that the mean, it is possible that the mean will throw you off. Okay, and we are going to be seeing that in the practicals here. So let's look at mode. The mode is the most frequently occurring value in a data set. It is particularly useful in categorical or discrete data set. So the mode is that number, that occurrence, that number that has the highest occurrence. Say, if you want to look at a repeating income, for instance, the highest frequency of that repeating income is what will be called the mode at this point. Okay, so let us begin with the practicals. We have talked about the concept, basically had an understanding of the concept, but let us see how this can impact our decisions, okay? So we are going to be starting with the measures of central tendencies here that we have. I think we have mean, as we have mean, we have median. So let's begin with those, okay? So we'll be using Python. I'll be explaining the codes as we progress. So the first thing we'll have to do is to import our libraries, okay? So we are going to be using pandas for data handling. We are going to be using matplotlib library for plotting and Seaborn for statistical plots, okay? So I've written the codes as I usually do so that it will be easy for us to explain as we go. So I am using Spider as my IDE, okay? So Spider can be downloaded from Anaconda Navigator, okay? So I think we have a video on how to install that. You can also use it on the go. So you can also do this using Google Colab, okay? So you can search on Google for Google Colab, create a new notebook, and you'll be able to do this as well. Okay, you'll be able to do this as well. All right. So let us go on. So now import pandas as PD. Pandas is used for data handling, as I've labeled. Matplotlib is used for plotting, and we're using Seaborn for statistical plots. So now what we have done with setting the style for the plot here is to ensure that we have a clear white grid, okay? So that is the style we have set, and you can see we use SNS because we said import Seaborn as SNS, okay? So let us now provide the data frame, all right? So we are studying daily earnings of 15 gig workers in Nigeria, okay? That is what we are doing. So now this is it. So we collected data from 15 gig workers, and we just wanted to check the mean. We want to check the median. We want to check the mode of these data. From there, we will progress to other parts of this class. So we created a list called earnings, right? This is a list called earnings. So in Python, the difference between a list and a tuple is basically in the parentheses, okay? It's basically in the parentheses. All right? So you see that here we use square brackets, okay? So this makes it a list. So let's go on. Now, we need to determine the three items we want to determine now: the mean, the median, and the mode. So let's go ahead and determine that, okay? All right, let me explain this. So we have a list. So we need to convert that list to a data frame using pandas. So we call this data frame df, okay? And so basically this df can be anything. You can give it any title that you like, all right? And because we are using pandas, okay, and we remember we said import pandas as PD, so we say pd.dataframe, all right? So we are converting this list now that I told you earlier, which is called earnings. We are converting it to a data frame, and in that data frame, we'll just have a column called daily earnings, okay? So now we go ahead. This one now just display few columns, few rows rather. The data frame.head display few rows of your data frame in case you have a larger data set. you can determine determine the number of rows you want to see. If it's 5 rows, 10 rows by using this, okay? So now let's go to calculate the average, which is the mean. So we say mean equals to, so the data frame we are referring to is daily earnings, just as we have it here, dot mean, right? We calculate the median. We go use the same process. We say dot median. Then for the mode, we want it to return, we don't want it to return the list, right? The entire list if it doesn't find a mode. That is why I will say dot values and 0 in square brackets. As usual, if we must go ahead to see our results, we will use the print function. But here in the print, to use the print function here, we use the S string. To use the S string here is because we want to give it a label, that right? To put a label within the variable. So if we go ahead and run our code now, you see that we now have the mean, okay? This is the mean of this value, this is the median, and this is the mode. So if we look at what we did during the concept, now, if you see, we have not, the reason why we imported matplotlib is because we want to visualize this, right? And I don't want to go back to, say, import matplotlib. I could import it later, right, as I need it. That is why you see here, say, matplotlib imported but unused, okay? That's why you have this. So by the time I put the section for the matplotlib, you see that it will not show that again. So I had to do this because it's a quick class. So we look at it, see the working, and understand the concept. So if we look at the mean now, the mean is the average. That is all of these values added and divided by the number of values, right? Please, can you hear me?
Yes, sir. I can hear you, sir.
All right.
Yes, sir. Yes, sir. Yes.
Okay. All right, let's go on. So please let us now visualize what we have and explain it better. Remembering what we said, that imagine that we have a mean of 24,000, right? It is quite misinforming if we go ahead and say that the mean income of a gig worker in Nigeria is 24,000 naira, whereas most of the people in that group earn way less than 10,000 naira. You can see you have more: 5,000, 5,200, 5,300, 5,100, 4,900, 550, 5,150, 8,000, 750, 7,200. Then you have about few people here earning way higher. And because these values here are very high, it will distort the mean, right? It will make the mean not a realistic picture of what the center should be, because the mean represents the center, okay? So let's go ahead and visualize this and see. All right, so let me explain this. This is where we ended before. So now, remember, I told you that when we write the area for the matplotlib, we are not going to see that no information sign anymore. So we said import matplotlib.pipelot as PLT. So if we want to discuss or write code for the matplotlib or the matplot library, we are going to start with PLT. Okay, and that is what we have done here. So we need to set up the canvas first. We need to set up the size. Okay, so that is what we did here. PLT.figure, then fig size 10 by 5. Okay, then we want to visualize this using a histogram. And remember why we use Seaborn. We said we want to use Seaborn for our statistical plots. And so we are using Seaborn here and the histoplot to represent the daily earnings data frame, right? And so we give the characteristics of the histogram, right? Then we add vertical lines and indicate the colors. For instance, here we want the mean color, right, to be red. The mean will be red, and the line will be in this format, dotted lines. And the label, here we still use the F string, will be mean, and you have the values here in the label as a label side of that. Then we do the same for the median and for the mode. Then for the labels of the plot title will be distribution of daily gig earnings. The X label will be earning in Naira, and the Y label will be frequency. Okay, now we close this with plot.show. Okay, so if we run this, we are going to, on the plot area here, we are going to see that we have plotted it exactly as we have indicated. So this gives us a visual to actually see the distortion that can result from the mean having values that are skewed. Okay, so value may be skewed to the right or skewed to the left. Okay, so this distribution, as you can see from this chart, is highly skewed. First, remember that you can see the mean. The mean is the red line, okay? The median is the green line, and the mode is the blue line, okay? So now, if you look at the left side of this histogram, if you look at the left side, you can see that majority of the workers earning, between 4,900 as you have here to 8,000 make up the majority of this left side. On the right side, only a few workers. Remember, those who earn 50,000, 55,000, 60,000, 70,000, 80,000. Just about few of them, if you want to count the frequency here. So you can see that we have 10 of them. And that is clearly visualized here in our visualization. You see, we have 10 within that range. On the right side, however, you see that we have in the range, say between, let's say between in the 50,000 range, you just have about 2%, that is 50 to 55,000. You have two, then one for 60,000, one for 70,000, one for 80,000. So that is what we are visualizing here. So let's ask ourselves this question: why the statistics diverge drastically? So the mean that we calculated, if you look at the mean here that we calculated earlier, our mean was 24,893 naira, 33 kobo, right? So this mean now is artificially inflated by the extreme high earners. These extreme high earners here, the 50,000 and above. So it's inflated, okay? Thus, misleading for understanding typical earnings. So if you say a typical gig worker in Nigeria earns 24,000 naira, it will be misleading because it will not be the true image. Now, when we look at the median now, the median gave us 7,200. So if I ask this question now, does the mean give us a true picture? What will you say to that question? Does the mean give us a true picture in this case?
No, the mean is not reflecting the real picture.
Excellent. The mean is not reflecting the real picture. That is because the data is skewed. Okay, it is skewed. We have many low income earners within that gig economy. We have just about very few, a handful of high earners. So it doesn't give us the actual picture. So for us to take that average will be misleading. So let's look at the median now. Our median is 7,200. So the 7,200 represents the true center. Say 50% earn less and 50% earn more. So in this case, the median will represent the more reliable measure of the earning of gig workers in Nigeria. That in this case, okay? So what does mode help us do? Mode just help us reflect any clusters at the lower end. So that is what the mode will do. Help us to reflect the any clusters at the lower end. Okay. So let's look at the dashed lines, right? We said we had the mean, median, and mode. So the red we say is the mean. If you look at the red, it is in the far right due to outliers that are misleading, okay? So now the green, the median, is near the data cluster. So that is making it more reliable. Then the blue, which is the mode, is at the most common low value. So let's look at the KDE curve. That is the smooth line, okay? So the smooth line confirms the sharp peak at low earnings and long right tail, okay? So basically, the gig platform, in this case, have two tiers. So this could be our recommendation, that the gig platform have two tiers. We have majority workers earning modestly and a tiny elite group earning 10 times more. So we can agree that we have the low earners and the high earners. We can basically agree to that. So instead of just putting all of the earners together, and that is why segmentation is critical. Okay. We have basically looked at how skewed data can give us a false image of what our average is, right? So let us now discuss the concept of outlier. And we'll be beginning by defining what an outlier is before we progress in determining the outlier. Okay, so an outlier is a data point that lies significantly outside the range of the majority of the data. So an outlier could be an ultra-rich individual in income data. It can be an unusually high-priced customer in purchasing dataset. It can be an exceptional performance in sales teams. So I just got asked a question not long ago during the break. And the question was, are outliers always bad? No, outliers are not always bad data. Sometimes they are valuable insights. Okay, variable signals rather. Sometimes they are what? Valuable signals. So sometimes outliers are valuable signals, but they can distort the truth when ignored. Like in this case, it distorts the truth if we do ignore them, okay? Like giving us a false image of what the average earner earns, because truly the average earner does not earn that amount. So yes, there are situations when outliers suggest something wrong with our data. There are situations like, say, they defy real logic. Like for instance, you are studying, say, the speed of vehicles that are involved in road accidents. And then you get values that are not or outside the range of the speed gauge. You see that defies real logic. It doesn't make sense. Another example is that you are studying the temperature of a particular city in Nigeria, for instance, and you see extremely high temperatures in the data set in a region where you know that data or temperature never exceeds 35 degrees Celsius. So you begin to ask yourself this question: was data collected in Fahrenheit or in Celsius? But you see that traditionally, every data was collected, or all data was collected in Celsius. So there is no how that Celsius was converted to Fahrenheit. Then you know that, okay, something is wrong there. Okay, like the first example I gave, imagine a record of somebody or an accident vehicle exceeding 300 kilometers per hour. You begin to ask yourself, what kind of vehicle was the person driving? Is it possible that the car had a speed gauge over 300 kilometers per hour? So that is when you see that an outlier indicates something wrong with the data. So that still goes to violating known rules or boundaries. Another example here for defining real logic is that you are studying an age group. You know that you are studying an age group between, say, 20 to 60, and you get an age of, say, 75. That is outside your boundary. That is outside your known boundary, okay? Your boundary is 10 to or 20 to 60. There is no way a 75-year-old person should be there, okay? Another example for under defined logic is, say, you are studying age, you have no boundary, but you see an age, you see a participant age 200 years. But you begin to tell yourself that it doesn't make sense. I collected sample of those working in civil service. So how is somebody aged 200 years working in the civil service? So that defies logic. So now outliers can also originate from inconsistent processes and or a repeat pattern that suggests systemic error. I hope that is clear. I've answered that question. So let's go ahead to look at this. Okay, yes, I said something about when outliers suggest something is wrong. What of the time that outliers are not wrong data? For instance, if you are looking at a skewed data, for instance, say you are studying earnings of people, say income, you know that there is no how income will definitely have a strict range. There are those who will earn low and those who will earn very high. In fact, in the same industry, for instance, let's look at this now. You know, project managers. Now, for project managers, you say project managers may earn so amount. You want to research how project managers earn. It is also possible that even though they have the same qualifications, there are project managers who may be underemployed, right? We are just using that as an example, okay? And there are some who may seem overemployed depending on the industry, okay? Like a professional may be paid 200,000 in an organization, and the same professional somewhere else might be paid up to 700,000. So if you are studying it, it is possible that in your population, you either have those who are earning more higher or those who are earning low higher. So income can skew data. So in such situations, you are expecting a skewed data set. So you understand that you may have some outliers that are not necessarily outliers. So if we're just going to judge this data as outliers, let's look at this gig economy as those as say Bolt drivers, okay, as Bolt drivers. Some Bolt drivers earn so much in a day, some earn so less, depending on how many rides and their availability, right? All right, so let's go ahead now and look at how we can determine outliers. Let's look at how we can determine outliers using the interquartile range technique, and we are explaining that as we progress. Okay, so I'm just going to take this, all of it, and then I'll just compute the code at once, then explain everything quickly so that we will go back to the business of the day. Okay, so now, as we did earlier, when we're looking at mean and the rest, we had to import all the Python libraries that will help us with our analysis or perform our analysis. And so we have done the same here again. So we have earnings as we had in the previous, but I think a little change in the values to help us really get clear picture on this. Okay, so usually from here upward, it's clear already is what we had done before. But here now, we want to calculate the first quartile and the third quartile. And the first quartile, that's the Q1, is a 25th percentile. Okay, Q1 is 25th percentile, while Q3 is what? 75th percentile. Okay, so it's basically like we are saying Q1 equals to this, the data frame, right? That is this list we converted to the data frame and call it daily earnings. So we are basically multiplying with this that 25th percentile and the 75th percentile to get the first quartile and the third quartile. So I believe you understand that the 25th percentile, which is like 25%, is 0.25. You understand why we had to do it that way. Okay. So now, to calculate the interquartile range is calculated as interquartile range. We subtract the 25th percentile from the 75th percentile. That is why we have IQR equals Q3 minus Q1. So we now define the boundaries for outliers. And in defining the boundaries for outliers, we use the Tukey's method. Okay. So we use the Tukey's method. So we are saying that in this situation here, we are saying that values should not be below, that is the first quartile, and values should not be above the third quartile. So that is what we mean here. So this is a standard in statistics where we subtract 1.5 or the multiplication of 1.5 times the interquartile range we calculated here from our first quartile, which we remember is the 25th percentile of our distribution. We are also going to print our answer for the interquartile range, the range that we calculated, and then we are going to print an outlier threshold. Remember, I said the outlier shouldn't, using the method now, should not be below this lower bound, right? It shouldn't be below this lower bound, and it shouldn't be above the upper bound. So we are using this lower bound and the upper bound here, okay? We are saying that for here, we want to filter outliers. Oh, sorry, here, the threshold, the lower bound or the upper bound. So we set that threshold to be printed. So we want to filter outliers, and we want outliers to be printed as outliers detected, okay? So that is why we say outliers here, and we say outliers are values that will be below what? Below lower bound, and values that will be what? Above upper bound, because we define outliers again as values that are below the lower bound and above the upper bound. So here we are using a box plot. Remember, the pandas is for our data frame. The Seaborn is for our statistical analysis, okay? Then we have the matplotlib for our visualization. So this Seaborn is what we use for our box plot. Then the matplotlib is what we use to determine the size of the plot, the title of the plot, the label of the plot, and to print the plot. Okay, so let's go ahead and run this and see. Okay, so now this is the box plot that we have. If you look at this very well now, we have the answer of our 25th percentile of our distribution. We have the answer for our 75th percentile of our distribution. We have the answer for our interquartile range, which is the quartile 3 or the third quartile minus the first quartile, right? Then we have the outlier threshold that we determined here, and then outliers detected that we determined when we're filtering the outliers. So here, basically, outliers are what? The 50,000, you can see the 50,000, 60,000, and 80,000. Those are the outliers, okay? All right. So now, in this case, why do we have to determine the outliers when we are certain that this data is skewed already? We are doing this because we want to use the outliers. We want our data or our analysis to be correct. We want to come to a correct conclusion, because if we were to use this for a strategy, which we'll see shortly, that if we don't use it properly, we may be misguided, okay? So you can see the outliers here for 50 as the dots here, okay, and 80. All right. So the box plots of the daily earnings that we have here shows that most gig workers earn approximately 5,000 naira, right? You can see in the first quartile, and approximately 8,000. We have 7,750. So approximately 8,000 in the third quartile per day, with a median of, say, remember we had a median of around 7,200, indicating that half of workers earn below this point. So we have the interquartile range at approximately 3,000, that is 2,725, okay? So this highlights that typical earnings are tightly clustered, while the upper whiskers to around 8,000. So the highest non-outlier value is that 8,000, okay? Meanwhile, we have small numbers of extreme outliers ending, so between 50,000 to 80,000, okay, as you can see here, all right? So this is clearly skewed to the right and confirmed by the median's position closer to the top of the box, okay? So this goes to show what we have been discussing. So as a result, the mean that we had earlier is heavily distorted and misleading, making the median a more accurate measure of central tendency in skewed data, okay, in skewed data. So that is one of the reasons why we have to look at this again, okay? So why outliers are important in economic analysis is that, for instance, in labor economics, outliers can mislead policymakers about average earnings. Imagine a politician, for instance, drafting a policy about average earning based on 24,000. That wouldn't be correct. In price discrimination, identifying outlier customers let business create premium pricing tiers. Like I said earlier, it's possible now to segment customers into low, medium, and high earners for price discrimination. We are going to price discrimination now shortly. So in customer segmentation, ignoring outliers may make you miss high-value customers or incorrectly average the value or average out values for everyone, okay? So let us look at price discrimination quickly, and that will be the final thing we'll be discussing about so that you can get a clear picture of how this wraps up, okay? And as usual, I have it down, so I will just take it, and because it's just similar code, I just want you to, let's have it in a way that is not confusing, okay? So I hope you can see my screen.
Yes, sir.
Yes, sir.
All right. So now we have everything as we had, except that we are defining, we had everything here as we had earlier, except that now we are defining our earning quantiles, okay? We are defining our earning quantiles. So we define low threshold as the quantile of 33%, say 33%, and high threshold as the quantile from 0.66. So now we defined a function here called assign segment, okay? Use the if function through two conditions. In a situation where earning is less than or equal to low threshold, let it return low income. In a situation where earning is less than or equal to high threshold, let it middle income. Else, that is a situation where we have what is it called? Earning higher than or equal to high threshold, let it be high income. So we did our data frame as usual, segment, define a segment, then this data frame will be equal to this data frame that is basically talking about the daily earnings. Okay, then as usual, we are plotting a histogram, right, with earnings colored by segments. That is high earners, low earners, and medium earners. Okay, so now I can take these out quickly first. Let me take these out quickly first, and let's work with this first. So before we talk about price discrimination, let us segment our customers based on the values we have been working on. Let's segment our customers, okay? So if we segment our customers, you see that we have our visualization. You see that we have the daily earnings as usual based on our segmentation of using quantiles. You can see that we have low income earners, right? Based on the segment we have defined here. Then we have medium income earners, okay? So that is what we have visualized here already. And you can see that we have more people on the low income than we have on the high income, okay? Okay, so we have more people on the low income than we have on the high income, and it's clearly revealed here in the what is it called, in the histogram. Okay, so basically what the kind of result we have been getting so far, even when we look at the box plot and the histogram we did to identify measures of central tendency, when we look at mean and median, okay, you can see that we have similar distributions. Okay, now to the theory of price discrimination. You know that, let's look at it this way. For price discrimination, you know that when you go to the market, for instance, let's look at this. When you go to the market, sometimes you price a commodity and the seller looks at you and tells you a price. Sometimes, or most often, that price you are given is not the price of the product, it's the price the seller deems it fit that you will be able to pay. Okay, that's why you see in our local market, a customer will say, no look me, oh, no look me, oh. You understand? No look me, give me this price, oh. You understand? Who has experienced that? Can you quickly give us your experience so that we'll move on? Anybody understands what I'm trying to say?
Yes, sir. I actually do understand, sir. For example, when I was in school, there is this popular concept that Yahoo boys have made most of the things that we buy expensive, because once they look at them and you appear to be like a Yahoo boy, they give you a very high price, because obviously they think you should be able to afford it, and of course maybe because they think you did not really sweat for the money, so they just inflate the price so that
Yeah.
they can match up with the person they are looking at.
Okay, so that is excellent. You know, price discrimination is a pricing strategy where the same product or service is sold at different prices to different consumer groups, just like you have stated. Okay, and this is not because of cost difference, but due to willingness or ability to pay. For instance, you go and buy something now, and somebody tells you later that the thing is not that expensive, that they just bought it somewhere else for a cheaper price. So when you go to buy something, usually the seller, and it's very common in this part of the world, seller looks at you and say, this is how much I can give. And sometimes, no matter how you bargain, they are not budging. They are not budging because they feel you can earn it, they feel you can get it. Meanwhile, somebody else will go and get it at a different price. So there are various factors, but the major factor there is the perception of the seller, how the seller perceives that you be able to afford it. And I have been in a shop where somebody came to buy something and the person asked, do you have this? And the response they gave was so poor, was so bad. The person say, we get them, but no be the one where you they buy. I don't know if you get the point. We get them, but no be the one where you they buy. You understand? Sometimes you hear those kind of things, and is because of price discrimination. So there are 3 degrees to price discrimination. The first degree is the perfect one, where each customer is charged the maximum they are willing to pay. That is a perfect one, where you go to a shop or go to a market and you are told the product is 10,000 naira, for instance, and you are able to beat the price down to, say, maybe 5,000 naira, the best price. You understand? In negotiation, you have a zone of possible agreements, ZOPA. Why? You understand? So then that perfect scenario is a scenario where everybody that comes get the same price and the bargaining starts. And when it gets to the zone where there should be a possible agreement, like when you are going to market, for instance, you say, my budget for this product is 5,000. So that 5,000 may, for you, be that a zone where you are not willing to negotiate past. For the seller might be that, okay, I'm not willing to take less than 3,000 for this product. So with that, the negotiation process is perfect in the sense that there is no price discrimination that is harsh. The second degree is prices vary based on quantity of products version. For instance, bulk version. When you are buying something in bulk, there's usually the discount given than when you buy a singular item. The third degree is prices vary based on consumer groups. They might sell something to a student for a different price, to a worker for a different price. That is low income earner, premium users. You understand that? Okay. Then you might do price discrimination, or price may be discriminated following that that degree. So remember the first degree, the second degree, and the third degree. Okay. So how does statistics enable price discrimination? So you see now that we have estimated income. We have estimated income here. The fact that we can estimate income, we can basically use the estimated income for price discrimination. So you can also do price discrimination based on average spending. That is the mean per group. You can detect high spenders, that is outliers, to offer premium versions. A business can say, oh, we have high spenders, and so we can segment premium spenders from other spenders, okay? You can do that. Then you can target mid-range or low income with tailored discounts, okay? Basically, let me explain something. Look at the milk industry, or beverage industry. You have the sachet, you have the medium-sized tins, you have the large tins, okay? Basically, serving various parts of consumers, or various segments of consumers. You know that there's more chances that you have more sachet in the market than you have medium tins of beverages. There are more chances that you have, excuse me, medium tins of beverages in the market than you have the very large tins in the market. That is because when you look at the segmentation, you have more people on the low income than you have on the medium income. You have more people on the medium income than you have on the high income. So that can help businesses target their customer better with product and service offerings. Is that clear?
Yes, sir.
Yes, sir.
All right. So we have successfully come to the end of what we have planned today. So do you have any question to ask? You have, before you ask your question, you are going to have your class, not classwork, this time, not group work, individual work. You are going to be given that, send that to your group as the class ends now, and it's to be submitted Friday before close of work. Okay, so do we have any question? Any expectation, anything you want to get clarity on, basically, you can use the opportunity as well quickly.
Okay, sir. Yeah, thank you for the class, sir. But I would like to ask that data accuracy, like I mean the how correct a data is it the job of an analyst to identify whether a data is correct or not? Or like for example, this analysis that we're doing here where we look at the outliers and all this from this data sets that we have,
Yeah.
is is it like our job to always verify some of these data, or is it because of this price discrimination that we are doing this?
No, it's the job of the analyst, because the job of the analyst is not just to, it's just like, I'll put it this way. A driver is hired to drive, but the driver cares for the health of the car. The car is not owned by the driver. I don't know if you are getting my analogy. The car is not owned by the driver. I own a car, I buy a car, I have full right to that car. I hire a driver. The driver is meant to drive me, but the driver is also responsible for the health of the car and the performance of the car. So as data analyst, you are responsible for the quality of the data. You may not be responsible from the beginning because you never contributed to the collection of the data, but your responsibility begins when the data is handed over to you. You are to inspect your data to ensure that the data follows every logical sense or logical conclusion that the data is of high quality. Because look at it as something that destroys your image or your reputation. When you go ahead to analyze the data that is wrong, your analysis is wrong. So you did not contribute to the wrong data collection, but your result is wrong. So whatever will impact your result as a professional should be something that is critical for you to examine. I don't know if you get the point.
Yes, I get it, sir.
Okay. If a driver drives his bus and stops in the middle of the road, the boss wouldn't take the responsibility that the car stopped in the middle of the road. The driver will take the responsibility. Even if the car ran out of fuel or diesel, the driver will take the responsibility, because it is the driver's responsibility to cater for the health of the car.
I have a question, sir.
All right, go on, please.
Okay, so according to the scenario that you just gave, so
Yes.
what is the role of a data manager in all this? Like a role of a data manager, because I had issues with one data manager last week. I wanted to like send the message to the group and ask you the question, but maybe if you can answer it now.
Okay, yes. The role of the data manager is to manage data. Okay, is to manage the data, definitely. But like I said, imagine now data have various sources from which they come from. Now, is it a field data that is entered? If it's data that is entered manually, there are chances. You already know that there are chances of errors while entering data. Now, a data manager is supposed to ensure that data is validated, that in fact, the data entry process is validated so that data that is deemed wrong will not be imputed in the first place. But as an analyst, you have to ensure that the data that you are given to work with is at par with what you are working with. You understand the business case, you understand the range and so on. So you have to do a diagnosis on the data to ensure that what you are giving is accurate. And if it's not accurate, you go back to the data manager to clarify. The idea that we work together in a team is that we can trust each other. We should be able to trust each other that the person in charge of ensuring that the data is managed properly have managed or have done their job. It is essential that we are able to trust. But personally, I will say that while I trust, especially if it's something that we don't have to work hand in hand as a team, you hand over the data to me to work on. I have to be in constant communication with you when I find something that is not supposed to be. And I will not assume, right? The key there is assumption. I will not assume that the data will be in a good health or in the health that is meant to be for my analysis. So I will not want to assume that way. I will want to do my diagnosis to be certain that what I have is actually what it is that I need to work on. For instance, if you look at basic methods that we can use to identify maybe if outliers exist, or we can even do that as simply as filtering or aggregating, right? So we can simply just do those things, right? Or yesterday in my one of my classes, I told the student that to find an abnormality in data, you can simply just put your values or put them in ascending order. Is it descending order, right? For instance, if you have, say, you understand that the age 25 should be the highest age, because of how large and dense the data may be, you may not really be able to just scroll, or in case you don't want to do any analysis to identify if there are issues with the data, you can just order in descending order. And then you can see the highest that you have. If the highest is not in that range, something is wrong somewhere. Then again, I told him about grouping. Okay, I told him about grouping. You can also group your data easily to see if you have issues with the data. So it may not be something very tedious that you have to do. It may just be a simple diagnosis, and you'll find out that you have issues with the data. So, Oluwadamilola, have I answered your question, or you have something
Yes,
more to
sir.
add?
Yes, I
Okay, is the issue something you can speak publicly about?
Yes. So my second question is, when it comes to Google Sheets, Power BI, Tableau, and Excel,
Yes.
that's Excel workbook, which is the best tool for building a dashboard, like an interactive dashboard, a detailed interactive dashboard?
Okay, you put Power BI, you say Power BI, Tableau, Excel, and Google Sheet. So I want to separate these items you just call, or group them into two groups. I want to group based on business intelligence and just data entry and management. Let me group them that way. Now, Excel and Google Sheet are spreadsheet applications. They are spreadsheet applications that have the ability to help you transform your data. All right. And again, it now depends on the size of the data. If the data is very large, it just serves the purpose of putting your data into tables. They have functions as well that can help you transform your data, maybe get summaries of your data, perform calculations. Excel have a robust function that can help you move from statistics to engineering to finance, and so on and so forth, right? With robust functions. Okay. Now, the other two are visualization, strictly visualization applications. Yes, you can perform and see transform within Power BI, but the beauty of Power BI and Tableau is that they are best suited for interactive charts that forms interactive reports and what we call interactive dashboards. Although you can still visualize, say, slicers and the rest in Excel, but you don't have the freedom as you will have in Power BI and Tableau. Okay?
Okay, sir. Thank you, sir.
You're welcome. So do we have any other question? Whether it's data analytics generally or in relation to what we have discussed today?
So I have a question.
Okay, Fortress, go on.
So the question is about the assignment that we are submitting on Friday.
Yeah.
What exactly are we doing? I didn't get it when you said it. My network was interrupting then.
Okay, the assignment is this, right? If you look at this, I know that calculating average, for some of you who are not beginners, I know that calculating an average is not something that is new to you. You have been calculating average for basically a long time. Even somebody who is new to data analytics, if you explain to them what an average, a mean means, that is average, you say, oh, I've calculated average, or I've calculated average mean earnings rather, and so on. So average is not new. But concepts like maybe median and mode may be confusing sometimes, right? And some people may not really know, but it's not that difficult to grasp. But again, the goal of doing this is that we understand their applications. We understand their applications, and we understand when a simple average is not just a simple average. You understand? For a novice, an average is just put some group of numbers together divided by the total numbers of occurrence. Okay, let's assume by the total numbers of the values rather. Let's assume we have 25 persons. Let's put their age together, divide it by 25, and we'll get the average age. But the data is skewed in the sense, will be skewed rather, if you have in that group, let's say you go to a market and you just want to say you want to calculate average age. Now, the average age might not give you an average age, an actual average age, because in that market store, you have a shop owner who is about 61. And assuming you just have 61, 65, 55, and the rest are young guys, 20 and the rest, that average may be skewed, because if you look at it in the distribution, it might not be a bell curve, right? It will not be a bell curve where you have the low end, the high end, and the medium end. I don't know if you have heard this, that many people, if we look at the height, okay, let me use height as an example. If you look at the height of people aged 10 years, you see that majority of the 10 years old will have the height close to the middle, right? You might have an average height of, say, maybe 2 feet something, right? You see that majority of the people, of the population you study, will be close to the center. You just have very few persons to the left and very few persons to the right. Almost everybody will be in the center. That is in a distribution that is normal. Okay? But again, if, for instance, while collecting the data, you get some heights that are too tall, you might have, or those that are too short, you might have the data skewed. So that's the importance of what we have done. So what we want you now to do is to perform your own analysis, find your own a data set, right? And determine it. Because some of you are gurus in Python already. Some of you might just be new people in Python and want to just try some things, but just go ahead and try it. You ask questions and you get clarity or clarification. Now, we want you to get your own data range. We want you to determine the mean, the median, and the mode. We want you to tell us, how does this help you in segmenting, right? And we are using income, so use income. How does it help you in segmenting? How does this help you in price discrimination? Okay. Now, why is it important that we looked at this in relation to price discrimination this morning? Remember, we are looking at business intelligence, right? And as a BI expert, you may be analyzing sales data, right? And the sales data may be used as what? As building strategies, or as framework for building strategies. So in that case, without the knowledge of theories like price discrimination, you won't be able to make recommendations. And without understanding how outliers, whether positive or negative, or the impact outliers have, whether positive or negative, you won't be able to deal with your data very well, or your recommendations very well. So that is why we are giving you, I'm going to post the questions to the group And we want you to internalize this because this is what sharpens your knowledge about what is expected of you sometimes when you look at data. Okay? But the questions as it is, I will post them to the group. Okay? Portrait, did you get that?
All right, sir. Thank you, sir.
All right,
Yes.
you're welcome. So do we have any questions so that we close? All right. In the absence of any question, let's call it a day. I wish you all an excellent day ahead. Stay blessed. Remember to work on your research. It's going to be a game changer. Okay? Well done, everyone. Bye.
Thank you, sir.
You're welcome.